All right, it's 9:16. I'm going to continue on. You've all seen this before, so you know where we are in here. I just want to give you a little bit of warning, advance notice, whatever you want to call it. So we've done everything in sections 1 and 2. After today and after next week, we're basically done with section 3, which, as you can tell, because that's all that's left, we got 4, 5, and 6. We're probably going to do little to nothing with 6, just so you know. 4, like I said, I'd like to, a week from tomorrow, go over chapter 17. I think that would help you going into the break. You may agree, you may not agree. All right, but we're going to spend a lot of time on 18, 19, and 20. Probably not going to even hit on 21 with files and data streams. I've done lectures on those, like on the chapter material and the PowerPoints. We're not going to go over XML files. I'd like to at least be able to show you link and or the entity framework, because it's kind of advanced database stuff. All right, so that's pretty much what we've got left. All right, and we've got about 15 or so pages left in this chapter, so let's just get to that. So we left off here, the code for the product list class. As it says, the next figure will show the code for this class used to hold the book and the software objects. As mentioned, the class inherits the product class. All right. As a result, it says the basic functions of the product list class, such as the ability to hold multiple objects, are provided by the base class. Remember, they showed you a couple reasons that inheritance is being used. All right. It says, however, the product list class does provide an implementation of an add method that hides the add method that's available from the list product. In other words, we want to make sure we're adding the right kind of product, that we are either adding a book product or we are adding a software product.
Something came up. I got it wrong.
Okay. All right. And then they mention here the last two methods of the product list class, those being the fill and save methods, aren't available from the base class. So in other words, they're not overridden from the parent, they're added to the child. Does that make sense to everybody? All right. All right. So what do we have here? Now notice what we're doing. We've already created a list of products. So what we're saying is product list is a child of list of products. All right. And you start to look at it like, what the heck? So we have defined our own class, and then we want to define a child of that class. I mean, there's no other way I can think of saying it. As it says here, modify the behavior of the add method of the parent. All right. And provide two new methods. We didn't have a fill in here. We didn't have a save in here, but the child has those. I think, at least I'm hoping that once you start seeing this in action and we go through an example, it'll make more sense to you. All right. I could be wrong with what I'm about to say, but what's happened historically in here is we go through this and people are just like, some of them just pick it up. Some people pick it up, but it takes longer. Some people very rarely, if ever, pick it up. Then we get into databases and you're like, hey, this ain't hard at all. I like this stuff. All right, and that's just the way it works. So as it says, the code for the product maintenance form is shown in the next figure. It says the first thing you should notice here is the code for the fill product box list box method. It says you may remember the code for this method in chapter 13 used a list. In contrast, because this chapter inherits the list product class, it uses a for each. Now, who cares? When you've got a for loop, the for loop can not only do things to everything that's in there, but it can change things. A for each loop, known as an enhanced for loop, typically the way that it's set up is you don't change anything in the loop. You're just looping through and showing things. But internally, the for each is supposed to, I believe at least, run a little bit faster than a standard for loop. Anything you do with a for each, you can do with a for. The reverse is not always true. All right. It says you can also see polymorphism at work in this for each loop. Here it adds the text to the items collection of the list box, and it calls the get display method for each product. Since it's overridden, it's going to be either calling the one for a book or it's going to be calling the one for software. And it can call the same method, but because of the fact that they're two different types of objects, even though they've got the same method name, it calls the right method for the right object. And again, that's polymorphism. All right. So again, here's that for each. And I've shown this kind of thing to people before, and they're like, okay, I get this somewhat. But you've got products here, and I'm sure that there's products. Where is P? You literally are defining it in the loop. That's like when you go into a for loop and you say int LCV equals 0, and you're creating a new loop control variable. P is the loop control variable in here. But notice when you use a for each, you don't have to do two things. You don't have to test it like you do in a standard for loop. You don't have to increment or decrement it like you do in a for loop. So this is more or less an enhanced for loop. This says what I want you to do is I want you basically to fill that list box. All right, and when you're filling the list box, based on this right here, look at the current object. You don't, you know, when we look at this, and we'll see it again in a minute, you don't typically just have all of your books, then all of your software. You might add a book, then some software, then another book. And this, if you want to put them in the same order in which you've added them, this is a very convenient way of doing it. All right. So next they show the code for the new product form. And as it says, here you can see that an event handler for the check changed event of the book radio button is used to set text. What the heck does that mean? All right. It means that by default, I've shown you this before, that if I can do it right now, but I don't think it really pays, that if I go and create a brand new project, so I come in and I create a brand new project for in Visual Studio, and all, you know, and I make it a GUI, and I double click on the form. There's nothing else on there but the form, and I double click on it. Does it make sense to you that what comes up is the form's load event? Because that's the default event for the form. If I put radio buttons on there and I double click a radio button, it comes up with check changed. That's the default event. All right. So what they're saying here is, okay, if the book is checked, we care about author. If the software button is checked, we care about version. Notice it's just an if and an else. There's only two radio buttons, right? We don't have an if, else, if, and an else. If one of them isn't checked, you're not doing anything. It doesn't make sense to do anything. All right? And when you save, you want to make sure you're saving it as the right type of object. So you're either saving it as a new book object, or you're saving it as a new software object. And then notice in here how the validator changes. Is present text author or version? The heck is that? Well, notice up here, the text author or version was either set to author or it was set to version. So in other words, we're able to, in our validator, check the same thing, because all that's checking for is the presence or the absence of a string field. All right. It doesn't make sense to make two of them. All right. It doesn't, because we're trying to use the same logic. We don't want to have to write two is validatas, where the only thing that's different is one of them checks the author and one of them checks the version. All right. All right. If you hated it so far, you'll probably hate it even more now, because they talk about how you can use casting. You can do your best to make an apple think that it's another kind of apple. It's usually very difficult, problematic, and you usually don't want to make an apple an orange. All right? It's not that you can't do it, but there, sometimes there are reasons that you don't do certain things. So it says, now that you've learned the basics of inheritance and you've seen the example of an application that uses it, we're ready for some additional techniques like casting objects and getting information about the object's type. Now, we already mentioned quite a while ago when I said the stuff that you get out of the box from object, one of the things was get type. And as it says, you can use that to get a type object that represents the type of whatever object it is you're working with. And they mention here, it says it lists some of the members of the type class. For example, you can use the name property to get the name of a type, such as product or book. We will be using a lot of this stuff when we get into databases. Now, I've always got my choice when I teach this, when we get into the database section, because we're coming right off of object-oriented programming. And people either they're starting to get it or no, they're not. So most of the work we do with databases won't be object-oriented related. Did you hear that? It's not that it's not important. It's not that it couldn't be done. But we're moving on to something new, and I don't want to be stuck with those of you who are still struggling with the object-oriented stuff. Well, I never got that. Now I'm not going to get this. All right. Okay, so they mention here, it says the first example in this figure shows how you can get properties that display information about an object. They use the get type to get information about a book object. The second one says it shows how you can code an if statement to check for an object's type. Notice if you do that, you use what's called the type of operator. All right, we'll look at that in just a minute. The third shows another way to test an object's type. Now, the author is showing you three different ways of doing, three different things in here, and some of them are a bit repetitive. So why would he do that? Because out in the, quote, real world, unquote, people do things in different ways. Some people learn their stuff by going, they just learn it by hand. They literally sit down with a book and they teach themselves. Some people like you guys, you come into a classroom. Some people go to a boot camp. Some people use YouTube. And there is not one method, one way of doing things that everybody will agree on. All right, so they're showing you different ways of doing this. So the type class has got different things in it. All right, so notice in here, type T equals P dot get type. All right, so as it says, it returns a type object that corresponds to that object's type. Well, what type is it? You should know by looking right there. All right. So it should come back and it should give you the name space, the full name. And the full name is usually like the name space and the full, and the name, and the base type name. So you can get different types of information. All right. How to test an object, this is kind of an important one. If the get type is of type book, all right, you want to make sure that if somebody has just gone in and put in software information, that you don't put it in as a book. All right. And you might say, well, what's the harm? Technically, it'd work. Does it make sense to you that you're using either a string for the author or a string for the version? But it's going to think that the author's name is going to be like 4.5. And for the version, it's going to think it's something like T.S. Eliot, which doesn't make any sense. All right. And this is a very simple example, but as you'd guess, out in the real world, these examples get much more complex than this. All right. So as they mention here, every object has a get type that returns a type object. You can use the properties of the type class to get information about it. And it says the ones shown are only some of them. Notice it says there's more than 90 properties and methods of the type class. So before you go out and reinvent the wheel, take a look at what's out there and see if what you're looking for or what you want to do already exists. The easiest way, as it says, to test an object's type is to compare the type objects that's returned by the get type. The other way is, again, this way right here. I've used this. I don't think I've ever used that. All right. How to use casting with inheritance. This is another one. You know, when most of the time when people hear this, they're like, this is hard to wrap my head around. You know, again, if you're not taking the time to read what's in the book and look at the examples that are in the book, you're hurting yourselves. All right. And I hear this all the time. Well, I don't have the time. I don't have this. You know, then make the time. All right. I've had this happen before where I've had students they're in their third or their fourth class. First semester, they kind of breeze through it. They just get stuff. Second semester, they also pretty much breeze through it. Then they start letting off on the gas a little bit, and their A becomes a B. Okay, that's still good. It's better than average. Then they get to their last semester, all right, and it becomes a C. Well, that's 4 classes that you're basically weighted on in here when you go out to look for your job. And whether it's fair or unfair doesn't matter because I don't make the rules. But if you graduate from here and you've got 3 C's and a C plus, and you're being paired against somebody else who graduated from here who's got 4 A's, they're probably going to give higher preference to the person with the 4 A's. Whether that's fair or not doesn't really matter. But one of the things that's in here, as it says, a potentially confusing aspect of using inheritance is knowing when to cast objects explicitly. Remember, there's implicit and there's explicit. Implicit means the software's doing it. Explicit means you're doing it. So for example, when we've done stuff like this, if I say float salary, and I say float salary equals 1234.56, and then I say int my sal equals, and I say int salary, I believe that will return 1234 and throw away the decimal portion. Does that make sense to everybody? That's an explicit conversion. I'm doing it. All right. When I do this, and I got a string in here, you know, that I'm just going to call it in. And I say like write, enter salary. And then I say in equals read line. We've all done this before. You know what this is. All right. Then I say salary equals convert. Shouldn't say float there because we use double. Let's make it a decimal. Convert dot to decimal in. Everybody understand what I mean here? Well, we looked before, we put the word int in parentheses. That was an explicit cast. This is an implicit cast because we're calling built-in software to do the work we want to do. All right? And in much the same way, they start talking about explicit and implicit in here. It says the basic rule is that C# can implicitly cast a subclass to its base class, but you must use explicit casting if you want to treat a base class as one of its subclasses. What the hell does that mean? That means when it says you can cast a subclass to its base class, when you think about it, that means that you can cast a child to its parent, but you can't typically do it the other way. All right. So it says there's 2 methods in this figure that both call get display text to get the data in a more displayable format. All right. It says the first example accepts a product object. The second one, and the first one was display product. The second one, as it says, display book accepts a book object. The second example shows code that doesn't require casting. Then there's a third example. It says it's similar, but it assigns a new book object to a variable of type product. So they're going to run through these with you. The fourth one shows code that results in a casting exception. What does that mean? The key takeaway from that is if you try to do something and if you're not sure whether or not it'll work, you might want to put it into a try-catch block. Because if it does, remember, if you don't and you try to do an illegal cast, you're going to get an illegal cast exception and the program's going to stop. All right, but you may be able to recover if you put it into a try-catch block. Finally, the last example, as it says there, shows how you can use the as operator to avoid throwing an exception if a cast is invalid. So let's look at these. All right, so notice the difference between these. This one is going to call the products get display text. This is the parent one. You got product P. This one is the book. So you're calling the books display text. So this one will add the author. So this one will have the code, the description, and the price. This one will have the code, the description, the price, and the author. All right. So when you look here, notice what we're doing. It says code that doesn't require casting. Book B equals new book. Yeah, that's got all of our stuff. Display product B. Wait, we're calling display product here. We're not calling display book. Can you see this? What does that mean? It says casting is not required because book is a subclass of product. I don't think we'll get the author there, but it'll still work is what they're saying. All right. So here's one that does require casting. And we're going to be doing some casting in the database stuff, just so you know. You know, when we get to the database, it's going to be kind of like there's a 5 or 6 step process. Some of the steps you can do in a certain order, and some of them you can't do. You must do in a certain order. Does that make sense? I'm going to show you the order that you should follow all the time. Then what we're going to do is we're going to write a simple program, and then we're going to write another simple program, and then I'm going to say, after we write that program, guess what? Everything that we just did, there's a wizard that will do 100% of the work for you. You might, I want that. That's what I want to use. But we're going to write it without using the wizard so you understand what the wizard's doing. Because that's part of the problem that we've had in the past is people learn how to do things and use wizards, but they never peek under the hood. So if something doesn't work, they don't know what's actually happening in there. All right. Okay. So notice we're saying product P. All right. Now, since we want to use the book, we want to do the display book with P, we can't by default unless we cast it because book is expecting. All right. Yeah, it's a new book, but we're calling the display book of product. All right. So it says casting is required because display book accepts a book object. But this says product P. This is the first time you've looked at this where notice you've got one type of class on the left-hand side of the equal sign and another type of class on the right-hand side of the equal sign. All right. All right, here's one that will throw an exception. Well, why? Because we're creating a software object, but we're calling the display book. So what the display book is trying to do is it's trying to look in there and it's looking for, all right, an author, but it's not finding it. You say, well, there's a version. It doesn't know that. It's literally finding a member in there that it doesn't know what it is. All right. And then finally, as it says, there's the as operator. All right. It says passes null because P is not a software object. What's a software object? I don't know. I haven't even seen it in here. Maybe it was in here, maybe it wasn't. So the takeaways are shown on the bottom of the page. C# can implicitly cast a subclass to a base class. You must explicitly cast a base class object when a reference to one of the subclasses is required. If you attempt to cast a base class object to a subclass, an invalid cast exception is thrown, and you can use the as operator to cast one type to another type. Then if you're doing something illegal, so if this doesn't work, it just returns no. All right, you can check for that too in your code, but the code won't blow up. All right. Now, abstract classes are what we start to get into in the next chapter, but they mention them here to begin with. An abstract class is a class that cannot be instantiated. Again, I put that example up on the board before where we had mammal, then we had dog, then we had cat, then we had bird. You're probably not going to tell people, hey, I just bought a new mammal, or I just opened a bank account. When something is very generic in nature, you will quite often make it abstract. By putting the word abstract in there, that means you cannot use the new operator with it. All right? So it says it cannot be instantiated. To declare an abstract class, you include the abstract keyword in the class declaration. In this case, the product class is being made abstract. It doesn't really make a lot of sense to say, I want to add a new product. Well, we've got two kinds. No, it's a new product. Is it a book or is it software? No, it's a product. No, that doesn't make sense. When you include abstract properties and methods in an abstract class, you must override them in any non-abstract class. We'll look at that in a minute. All right, the methods are what are particularly important here. All right. So notice what they've done in here. Now it's public abstract class product. Other than that, it looks similar up to here. This looks the same as what we did before. So everything from here till right there, all the stuff you see in blue there, that looks the same as what we did before, except we've got the word abstract there. But what you haven't seen before and you see now is this is an abstract method. I've mentioned a term to you guys before, and hopefully when I mention the term, it's API, Application Program Interface. And I mentioned it's like a contract. You know, in just the same way, I get Sirius Radio. All right, I had to basically sign a contract or do the equivalent of that, and I have to renew it. And I've got to use it in the right way. So if I want, I can take Sirius now because they've changed it, so I can put it on this computer, I can put it on whatever I've got at home, I can, etc. But I've got to follow their rules. In much the same way, when you create an abstract class like this, all you do is you put the name of the class and any parameters that the class needs. That's it, no body. But since it's basically an API, any class that inherits from product now must have its own get display text. It must have a string, as it must return a string, and it must have a string passed into it for a separator. All right. Hopefully this is starting to put everything at least a little bit together for you. All right. So notice now, just like we did before, public class book product, same as before. Public string, same as before. All right. But notice what we have in here. We must override this. If we didn't put that in there, that it has a string and that it's passed in a string and it returns a string, if we didn't put that in, we'd get an error message. So what you typically do more than anything else is in the abstract class is you include abstract methods that you want any class that inherits from there. Now think about the example I gave you at the beginning of class. Now we come in and we make our employee class abstract. And we put those four fields in there: first name, last name, department name, and employee number. Now they're available to our piece workers, they're available to our salaried workers, to our commission workers, and our hourly workers. But we also put in here something like this that's called earnings. Because the earnings for an hourly worker, I'm going to need the hours worked, the hourly rate, and whether or not they have overtime. For a piece worker, I'll need to know how many pieces they make and the price they get per piece. For a commission worker, I need to know, do they have a base salary and what's their commission rate? For a salaried worker, that's like me. I've got a salary. You know, if I literally put a bed in here, I wouldn't. But if I put a bed in here and I slept in here and they let me stay 24/7, I don't get any more money for doing that. Back pre-COVID days, I used to come in here at 5, all right, every day. And I'd come in sometimes on weekends. My wife likes to shop anyway. She doesn't particularly like me coming along. So it worked out pretty well. Saturdays, usually I'd come in here and I'd work all day. Now I can't because there's nobody to scan me. All right, okay. So an abstract class is a class that can be inherited by other classes, but you cannot instantiate it. To make it abstract, you put the word abstract in the class declaration. It can contain properties, methods. In addition, as it says, it can contain abstract methods. You can put non-abstract methods in an abstract class. You don't see that a lot, but you can do it. All right. To create an abstract method, you use the abstract keyword and you omit any kind of body. So you just put in the return type, the name, and in parentheses, any parameters. To create an abstract property, you code the abstract keyword, and then you code an accessor, a get, a set, or both. All right. Abstract methods and properties are implicitly virtual. You can't code the word virtual. They must be overridden. That's why you create abstract methods, is so they can be overridden. When a subclass inherits an abstract class, all abstract methods and properties must be overridden. And you can look in here, and if you did notice, did we make these things abstract? No. The word abstract isn't in there. That's why book can use those directly. Okay. All right. It says there, in contrast to an abstract class that must be inherited, a sealed class can't be inherited. Okay, so when you think about it, you know, if we have our hierarchies here, showed you this before. Let's just, I'll make it real simple. Let's just have dog, period, dog. I think you'd all agree there's probably 50 types of dogs we could make off of that, right? And let's just say one of them we put here is beagle, right there. If I take that class and I make that class sealed, there cannot be any classes that come off of that. Does that make sense? It's recommended in object-oriented programming languages that you do the best you can to not make anything sealed. Making something sealed is almost like making it a constant. You can't modify it down below anymore. You can't make a class. So if we had a new kind of beagle, you know how they got all those golden doodles and all that stuff right now? Because I know I've got a brother with a golden doodle. I've got a niece with a golden doodle, etc. But there's schnoodles and there's all these other kinds of things. So maybe you want to make a Pekingese and a beagle and call it a peagle. And you want to put that underneath it. You can't do it if that class is sealed. There may be a reason for sealing a class, but always the recommendation is think about that long and hard, because what you're basically saying is now it can't be changed. As it says, because C# doesn't have to generate code that provides for inheritance and polymorphism when it compiles sealed classes, using them typically results in a performance benefit. So it says if you know that a class won't be used as a base class, you should consider making it a sealed class. The problem is a lot of times you just don't know. All right. So notice how you do this. Public sealed class book is a product. But that means you can't, if you ever wanted to break it up into any different kinds of books, you'd either have to remove the word sealed or you couldn't do it. Period. That's what they're saying. So a sealed class is a class that can't be inherited. To create a sealed class, you code the sealed keyword. Sealing does give you a minor performance bump, but again, you can only seal, well, they talk about it, and it says, this feature is rarely used in business applications. And that's it for this chapter. All right. Now, I haven't been going that long. It's 9:50, but I am going to take a quick little break. Let's take a break. At 10 o'clock exactly, I'm going to start up, and I'm going to start on chapter, this is 14, I think. We're going to go right into 15. All right.